So next chapter is all about psychrometric air processes. The first one is sensible heating. Sensible heating is represented by this process that is from left to right. So as you notice that the dry bulb temperature is increasing towards the right. Okay, so considering na ito yung ating heating coil. Okay, so let's take this as our heating coil. HC. So normally yung coil na yan, kapag meron tayong 3D drawing, okay, so we have fins, and then normally aluminum yung material, AL, and then meron tayong copper tubes inside. Okay, copper tubes, tapos dyan nagpo-flow yung ating, let's say, hot substance or hot working substance. So let's take this as H2. So of course, the purpose of this is to heat the air. So considering na ito yung ating condition at point A, so let's take this as 70 dry bulb. So that's here, 70. And then ang wet bulb natin is 54. So this is 50, 55. And this is, let's say, this is approximate point or condition. So the dew point temperature is around 40. Now the process from A to B, that is from 70, considering na yung air is nag-flow from this point to this point. From on coil, this is the on coil condition, that is technical term. Pag bago mag-enter ng coil, we call it on coil, okay? And then paglabas naman sa industry, we call it as off coil. So that is condition B or point B. So the point B is 100 degrees Fahrenheit dry bulb, and the wet bulb is 65. Okay, wet bulb is somewhere here. So ito yung ating process heating. So what you'll notice here is that the dew point temperature is the same. Okay, horizontal line. Okay, so dew point A is equivalent to B, and the same yung ating humidity ratio, constant siya. All right, so again, this is what we call process heating. Now we go to the sensible cooling. Sensible cooling is simply the reverse of sensible heating. Kaya lang ang direction is from right to left, as you can see in here. So considering na again, dry bulb temperature is 100. Okay, same here. 100, sorry. Nandito yung ating point. Okay, 100. And then 65 yung ating wet bulb. So ito yung ating wet bulb. This is the point. And then ang process natin is again from A to B. Ang value ng B is 70. That is somewhere here. And then ang wet bulb is nasa 54. Okay, so ito yung ating representation yan. That is 54, somewhere here. So this is the point. And then take note, yung dew point temperature again is the same. Kasi horizontal lang siya. So the process is from this point, that is A, to B. Again, this process normally occurs for cooling coil. So imagine again, meron tayong heat exchanger na tumatakbo doon sa ating tube is cold water or cold refrigerant. So now, pagka inobserbahan natin, considering again na ito yung RH, okay, so ito yung RH for heating. So for heating, okay, we can say this is, let's say, 20 or 30%. Example lang. Okay, 30%. And then here is around 70%. So pagka merong tayong heating, all right, so from 70% from high relative humidity to lower relative humidity. So baliktad naman pagka meron tayong cooling. So that is from A to B. So again, representation natin dito is 30% as an example, and then dito 70%. So pag cooling, as you notice, the relative humidity is increasing. Okay? Alright, so next is humidifying and dehumidifying. So humidifying basically, as the term implies, that's increasing the humidity content of the dry air. So imagine ito yung ating representation. So we eject steam, okay, through the nozzles, and then we will let the air pass through this. Okay, so meron tayong tinatawag na humidifier. Okay, so as you observe dito sa ating illustration, we have here on the vertical axis, meron tayong humidity ratio. So, considering na ito yung ating first point, okay, that is our A. So, ito yung ating A. And then, ito yung ating B, okay, paglabas. So, the air passes through here, and then as it passes through here, it will absorb some water or moisture. So, as a result, magkakaroon siya ng mas mataas na value ng humidity ratio or the water content of the air. So, ang process is almost isothermal. As you can see, isothermal humidification. Bakit? Because the dry bulb is almost constant. Nagbago lang is yung humidity ratio and of course, yung relative humidity. So, pag ganito yung process, as you can see, let's take this as 40%. Ito ay, let's say, around 90%. Okay, dito sa point na to. Okay, just an example. The reverse of this process is dehumidifying. So, the opposite yung direction. So, dehumidified, meaning to say less water content. This one is normally accomplished using silica gels, coal, yung mga desiccant materials. Okay, so you'll find this normally doon sa mga sapatos. Okay, para mawala yung amoy, ginagamitan natin ng silica gel o nilalagyan natin ng silica gel yung loob ng box ng sapatos so that it will absorb yung moisture, which is normally nagiging sanhi ng mabahong amoy. So, this process normally occurs also as isothermal. So, constant yung kanyang dry bulb temperature. So, considering na ito yung point na yan, A to B, so madali lang ang observation natin, the humidity ratio value will decrease. Kung ito yung ating relative humidity will also go down. Okay? Kung ito naman yung ating wet bulb, okay? So, in this case, let's say approximately 70 temperature WB. And this one is also temperature WB. So, mas mababa yung ating wet bulb temperature at the final condition or point B. The dew point temperature also will change. Okay? Mas bababa. Alright, so next process is cooling and dehumidification. So it's a combination lang kanina. We have cooling, that is from right to left, and then dehumidification, that is from top to down. Okay, so lagi ko lang ha. So this one is cooling, going to this direction, and dehumidification is in this direction. So kinumbine lang. So the tendency or the process is like this. Okay. This one is cooling, and this one is dehumidification. Okay. So normally, itong gantong process is nangyayari sa mga normal air conditioning units, sa mga fan coil units na ginagamit natin for cooling. Okay. So here is illustration ng cooling coil. Okay. Cooling coil A to B. So consider na ang dry bulb natin initially is 75, somewhere here. And then meron tayong 62 wet bulb temperature. Alright, and then dew point is approximately 55 degrees Fahrenheit. So pagka dumaan sa cooling coil, yung air, considering na yung airflow natin is from A to B, again, ito yung magiging process. So 50 yung ating dry bulb, so somewhere here, and then wet bulb is 47. Okay, so ito yon. So this is your point A, and this one is the point B. Direction is here. So, combination siya ng, again, cooling and dehumidification. The dew point temperature here is around 45. Okay, so yan yung ating illustration for cooling and dehumidification. So, mapapansin niyo dito, the relative humidity will increase. Okay, so ito yung, let's say, around 50%. This will be, since near yan dun sa saturation line, we can consider this as 90, 95, etc. Okay, so basta malapit sa 100. The next process is heating and humidification. So again, heating is from, kung ito yung ating dry bulb temperature, dB. Okay, so increasing yung ating from left to right. And the humidification, pababa yung humidity ratio. Okay, so ito yung ating A, ito yung ating B. So consider na yung ating dry bulb temperature at point A is 95. So ang result is pagka meron tayong heating, tataas yung ating dry bulb. So in this particular case or example, we have 126 and the rest of the property will follow. So as you notice here, pagka pinalo natin yan, yung wet bulb temperature, by the way, is almost constant. Ito yung ating T wet bulb for this kind of process. While the dew point temperature decreases. So kung ang value nito is nasa 66 or 67 degrees Fahrenheit, here the value is approximately 46. Again, in this particular example. All right. So next process is cooling and humidification. So pwede natin ulit gamitin yung ating psychrometric chart to represent this process. So cooling normally is from this point to this point. Okay? That is, the dry bulb normally goes down. And humidification, meaning to say, yung ating humidity ratio is pataas. Alright? Pataas yung ating value. So, this one is A to B. Okay? So, normally nangyayari to using yung pag gumagamit tayo ng water spray. So, normally meron tayong ganitong klaseng setup. And then nag-i-spray tayo. Hindi siya coil. Parang ano lang siya, pwedeng like for example cloth. Okay, special material for cooling and humidification. Tapos magku-flow yung air dyan. Normally may fan ka dyan to initiate the flow of the air. So this one is A towards B. So normally ang process ito is adiabatic. And as we know, adiabatic is Q is equivalent to 0. Okay, there's no heat. Ang characteristics niya is yung H is equivalent to constant, hindi nagbago. So, almost the same line sila ng wet bulb. Okay, so kanina pinakita ko kung saan yung location ng ating enthalpy. So, ito yung ating process again. So, meron tayong spray of water in here. Normally, ginagamit ito sa mga open places. Okay, like for example, terminal ng mga Trane or mga restaurants na may mga upuan sa labas ng building. Okay, so ito yung ating example. 95 dried bulb and then 73 yung wet bulb. Okay, so pagka pinakita mo yung process, the wet bulb must be constant. 73 pa rin yan. Same line. While the dry bulb, as you can see, mayroon tayong cooling effect. So the final temperature dry bulb is around 74.1 in this particular illustration or example. Then finally, we have heating and humidification. So heating is represented by this line or process. Okay, so pataas yung ating dry bulb temperature. So let's take this as A and then ito yung ating B. And then yung humidification naman, of course, is tataas yung value ng humidity. Okay, so kinumbine siya. So therefore, ang result is somewhere here. So let's take this as B prime. Alright? So that's the summary, quick summary of air processes that we can represent sa psychrometric chart.